Hello everyone, hope you all are doing very well. For those you are new to my channel, my name is Avkash and this video is the continuation of the previous video. In the previous video, as you can see already available at the YouTube, we have learned how you can take any existing LLM. The example here we have taken the OpenAI, the DaVinci GPT model, and using a large language model, you can actually fine-tune it with your own custom document. And then after you can query it. So part one has already been completed. And in this video, we are going to create a full application using the Gradio UI, which you could host anywhere you would want, local file system and Hugging Face as well. And you can create a UI which is more dynamic to fine-tune your custom LLM model with lots of PDF and text documents, and then you can ask query around those documents by loading the index which you have created based on your input documents. So our objective in this project is to create the Gradio UI based application, and here are the three different tabs which we are going to add in our application. The first tab, the second tab, and the third tab. In the first tab, we are going to set the OpenAI API key, and that key will be set as our OS environment variable. That's first tab job. In the second tab, we are going to drop either the TXT file or the PDF file as our source or the newer content which we want our LLM model to fine-tune with. And that's where it is. Once the index will be created for that given data, we will get a report here that the index has been created, and that index is saved in the local file system. After that, the third tab, where we will see how many indexes we have saved in our local file. Here, second, we can select a particular index which we are interested into and load that index. Once the index is loaded, it means that we have connectivity with the LLM model to connect with that index which we are going to ask question about. And that message will tell us that index is selected and loaded. And here in this area, we are going to ask question, and get answer button is going to take the question from here, and working with OpenAI LLM model through API, we are going to pass that question back to the OpenAI subsystem through API, and the result will come back here and result will be rendered here. So as long as the index JSON, which is the index of your previous document, is loaded here, you can ask as many as questions you want. However, every question is going to be taking the API call to the backend and the OpenAI backend, and that's where your answers will be coming out. And then here our job will be just to render the query results. This is the project which we have created earlier, fine-tune.py and the queryindex.py. So each file, one was used for fine-tuning, second was used loading the index, and then asking the question based on our index. So we are going to create a new file called tuning GradioUI.py. So that is our main file where we will write all the code related with our Gradio UI application. I would like to suggest you to visit this repo, DeepWorks, and here you will find the Developing Gradio based tabbed UI 2-part tutorial if you are new to learn how to create the multi-tabbed based Gradio UI, and then you can use that UI to create or showcase your Python application which anybody could use. You can create that application locally, and you can also host that application at the Hugging Face repo. So this is the Hugging Face, and where if you look into the My Spaces in my account, you will find that these are the three different spaces which I have created similar to projects like this. So these two resources are very important for you, and for any resource if you are looking into, you can always select the resource, and while this runtime is loading or it takes time, you can find the code, and that's where you will find all the code, multi-tabbed UI with the functional backend connectivity. So this is very important because I'm going to expedite the UI development first quickly. So this understanding is going to help you a lot, and the videos which are available in this page, you can actually go and visit my YouTube channel, and that's where you can learn in detail how to create the multi-tabbed UI. So these three resources are going to be very helpful for you. So we need to import Gradio as GR. Next, here we are creating a class GPT processing, that is for custom data processing with GPT and fine tuning. And here, as you can see, that we have some of these class specific properties. API key is not set, index folder is indexes. Here, as you can see, this index folder is going to be index data. UI object, I'm just coming there. That's where the whole UI related application setup will be there. API key status, selected index, as we have selected index status, these are just messages. And here we are creating a method which inside the class using self.ui object. This UI object is actually passed when this class is instantiated. So with self.ui object, first this code is going to does nothing, just create the UI and start the header, markdown header. In the next step, we are going to create the tabs interface because our objective is to build these three tabs. So let's write the tabs here. So here gr tabs, and we are going to create the tab items. So this is the tab interface, and this is a tab item 1, tab item 2, tab item 3. So OpenAI configuration, and as you can see, we need row 1. Row 1 has the 2 items, row 2 has the 1 item. So here is our row 1, OpenAI text box, and its password type, action, when click will happen, this button will be clicked, and then finally OpenAI status is there. And here we are using this API key status. API key status is here. So when this click happen and we validate this API key, we update this status. So this is the tab item very first. In the second tab, here is the second tab, we also have 2 rows. In first row there are 2 items, second row there is 1 item. Here we created the second tab where we are training with custom data, or you can say this is the fine tuning also. First, we are using the Gradio file component, so feed PDF in text file. Then click event happen, which set up the create index option operation, and this in the second row we actually generate the result if the index is set up. So this index setup result is also coming out from here. Right now there is no action. So this is the second tab. In the third tab, we have multiple row. First row where we are listing the index because we are saving the index in the local file system. So we are just loading all the files in that area. Here we are selecting the index. You can actually create the drop down. Just for expediting my code, I have just created a text box so I can manually type it. Loading index. So first, query custom data, first row. So we have created this where this action button is a button will load all the listed index. Next row, we will put a particular index in this text box, and then we will click this button to set that index. This line will tell us that our index is set. In the next line, we are going to query. So here is the query question, 5 lines. So this is the text box where we are going to type our question, And this is the action button where the click event will happen for us to send this question tags back to the OpenAI backend, and we are going to get result out. So that's what we have done here. And finally, this will be the output from this action, and that the output result will be written here, and it's using the 10 line, and that's what our tab number 3. So we have just created this class and this create UI, which actually render our whole UI code. Now we can create the main block. So here is our main, and very first we need to instantiate our class. So before even we do instantiate class, we need to do the blocks. So this gr.blocks is your hook to Gradio blocks method, which helps us to create the UI component. Then you are going to create the Gradio UI. This is just your object name. So Gradio UI is going to be use your what was the class name? GPT processing. So GPT processing is our class, and this GPT processing, remember, we have to pass the object in the instantiation. That's where we will take this my app object and pass here, which is type of GR blocks. And this Gradio UI is going to actually instantiate this UI. So this is the create UI. So we have created the UI. Now we need to write a launcher UI code. So we could say define launch UI, and this launch UI is actually going to do self.UI object. So this is the launcher for our object. So here we are going to say Gradio UI dot create UI, and then Gradio UI dot launch UI. So as you can see here, that this code is actually going to first load this method, which really lay out all our code, and then it's going to launch. So this is our code. This is the code which we would want to run first. Let's run it. This is the 7861. And as you can see that these are the 3 tabs which have created: tab 1, tab 2, tab 3. But there is no action associated in any of these buttons, because we have no code written. Oh, sorry, this one already had some action built into for the code, but there is no action built into because we haven't done any coding to create the actions associated with any of these UI components. So let's go next. Stop the run. Now we are going to start adding actions with each of these buttons. So we will start tab by tab. So as you can see here that this is the one action we have here. So set API action. Very first, click. This click action is actually going to have the 3 methods. That's where my previous tutorial is going to help. First, where you are going to create a method here. So method will be, let me just take this. So here is the method, and the method is update API status. What is going to happen when you are going to put the API key and this click event happen? That's what is associated here. So this update API status method is going to be called self.update API status, and here we need to pass the key. That will be the all the input variables, and that will be the all the output variables. So our input is OpenAPI key, and our output is going to be the OpenAPI status. So this OpenAPI key is actually the input in this method, that is API key. If API key is not none and the length of API key is greater than 0, then we will set this self.API key, this API key as the main API key status we will update, and in the os.environment we will set up the API key. That is similar to here OS, and then that's how we really do it. So we need to make sure that we actually import the OS in order to make this whole code work, otherwise you will get an error. And now you see that code has been set for updating OpenAPI status, and here is the self API we are setting up as an OpenAI key. And that's what the code for this very first tab is needed. Now we can go to second tab where our action is to, as you can see here, index setup action. So let's take index setup action, and that will be the second dot click. And here again we need to write a method. Let me take a method here, and as you can see here that we are loading the source data. So this source data will be the method here, then input, and then output, and that is going to be the self dot. Okay, now this method we really need to make sure understand it really as good as we can. So whenever in this tab, when somebody is going to drop file, we will get file object returned back from this component. That will be our input, and when this click is going to happen, this input which we have already kept in memory, because when a file was dropped, this component as a return is giving us a list of files. So this event, when the click happened, take these files, check whether they are PDF or text. If PDF, extract the text data. If text, just read the text data, and then after process it. Process means sending back to the OpenAPI backend, which is similar to fine-tuning, reading the text data, and then using this GPT simple vector index so that we could actually generate the index. So this is what we have used earlier. So I will be using exact same code here, and that's where the load source data is going to work. So this load source data will use input as a file. That's why if you see here, this source data is our input for this action, and this result label is the output. So this is our input, and this is our output coming out from here. So that's input, and then this file object is the input. So here is the file name. Then we are splitting the file extension, and we check that the extension is either .pdf or .txt. If it is a PDF, we actually parse the component content, and then if it is a txt, then we actually use this simple directory reader and pass this txt file, which is pretty much simple to this code. And that's how we actually load the source data. This code is not needed, so I will remove it. So one thing I wanted you to understand, so we have loaded this data, but that is not enough. We also need to save the loaded data into the disk. So we need to make sure that what we are doing is step by step. So in the next step, when this data is loaded, that is not a complete method. It means we are going to write another method, and let me take this. So what this method does, it actually index setup process the file. So let's replace this method index setup process rather than loads source data, because remember it's a three-step process: loading the data, and then using this simple loading this data using whether the library available with this GPT index or just using a PDF processor which can read the PDF file. So we need a PDF processor, and the library which we are using, LlamaIndex here, actually has the built-in PDF parser. So we could say from GPT Index dot readers dot, and here as you can see there are various readers available, different sources. So you can actually say file dot, and here you can see that various types of input files can be read, and it's going to use the dot document parser, and within the document parser you can say that you need a PDF parser. So now we got the PDF parser, and that's where this error will be gone. So now we know that whenever this click event happens here in this step 2, we are going to check whether these files which we have dropped, they are text or PDF, and we are using index setup process. So we load the source data that checks whether this is a PDF or TXT. In the PDF, what we do, we use the parser and then extract the content, and if there are multiples of PDF, then we actually create this document of type PDF. So from, and okay, it's a base type, so PDF type is a schema, so GPT Index dot, it's gonna be readers, that is schema dot base import documents. So this is the document which we are using, and that's where the document, so all the data which we have parsed after dropping to that Gradio UI file widget, now all that data is stored into this source data object which we have created here, and this source data object is the output of this load source data. And this source document, we check that it's a list, so there must be at least one source document, and if it is there, then we use this GPT simple vector index to pass the source document so that we can get the source index. That is exactly we do here. So here we are passing, and now we have index, and the only next step we need is to save data to the disk. So now we are creating this method called save index document, where we actually pass the index object which is coming out from this API, and the file name, whatever the source file name, because there could be multiple indexes, so we are using same file name and just call it JSON file. So here is our save index document method, which takes this source index out file name, and we just take the main file name without the file name only, without the with the extension, and then we just add the .json. Then we write that everything to the disk, and here we are using the same source index object save to disk. So this save to disk method is already part of that component, unable to save the index file. So that is our index setup process. So this method is ready, which will generate the index and show the message here. Now in the third step, we are going to list all the index, and then we can select a particular index so that we could query against that index. So let's complete that part as well, and then we will run the full code. Until now, if you would want to check your code, you will see here that, so running the code, we hit an error. We can look into the error, and it's the click and other events can be only called within the block context. Oh, I know what's the problem. So let me stop this, remove this. So what happens is that if you look into where our click events are, so our click events are at the level of here, and they are within here. So we need to go to the block. Block is actually inside here, because this is the UI object, which is actually here gr.blocks. So we need to move all of these events one level inside. That's it, because they have to be inside the block level. Now let's run again. And our error is gone. Working, all three tabs are working. So if we would want, we can actually validate these first two tabs, because these two tabs are going to help us set up the API key and generate the index from the source document which we would want to fine-tune our LLM model with. So let's take a quick look about our code if there is any issues. So we have output index data, so there is a typo, so index data. And second, we have this code. If the file is saved to the disk, we will set up this file out path. Otherwise, the file out path will be none. So there was a little typo here, mistake. So these are the two things we needed to fix our code. Now we can validate this code is ready. Reload. Let me use my OpenAI key. setting up the key. So key is set up. Second, we are going to drop a PDF document here. I have dropped the PDF document. So the Gradio file widget has already been processed, and we know the file size, everything that's already done. The heavy lifting is already done by the Gradio widget. When this click is going to happen, let's make sure that there is a breakpoint set. So here the index setup process. So let's set up a breakpoint here. Click breakpoint. First, load source data. Let's go inside here. We are just reading the file, understanding what is this extension, checking if the extension is PDF or .txt. If it's a PDF, we are using the PDF parser, which is a module part of our GPT Index library. We are parsing the PDF, extracting the content, and once the content is extracted PDF, we are just creating the source data object, and we are storing it. This code is going to help us if we have multiple of these files, and if our file would have been the txt, is just reading the file path completely and using this simple directory reader class available with the GPT Index to generate the source data. Now we have source data. Now we are going to check if the list of array where the source data is more than one, because at least we need one file over there. Then we are using GPT simple vector index, exact same thing here which we have used earlier in the fine-tuning method. We are generating the source index. At this point, request is going from source document as a text to backend OpenAI, and then index is coming back to us. So now we have the source index. You can take a look, source index here. This is all coming out from the GPT. You see GPT Index embeddings and then everything what we have got back. Now we just need to save this. So we already have this save index document method. Let's go inside. As you can see that we are just creating the output file name, and once the file name, we create the full path to make sure we are writing in the local file system, and then we are using this save to disk method, which is part of source index, which write back to the disk. And after file write is done, the file should be available in this area because that's the save to the disk method. And saved file is not none. It means we will get this whole message out. This message is our status message, and we can come out here. Console request, one request to the OpenAI was made. We can come back here, and as you can see that the index data folder must have this file, which is the JSON or the index against our PDF document. Let's look into here, and as you can see, this is our PDF JSON. You can open it, and that's pretty much you can see for your PDF. So these two tabs are working fine. Now we just really need to make sure to write code so that we can select the index, and then we can ask questions against or query against the index. So what is next here? In next, we need to index listing action, so we can get how many index we have in this file or in this folder. So let's write here dot click. First, we need to write a method which actually generate the lists. I already have method index listing. Index listing is the method input and the output. So in this action, there is no input, only output we have. So we can leave the output, this and input, nothing. And that's what this index listing is going to give us. It reads the index path wherever we are, that is our index folder, and it looks all the files, listing file. So if there are JSON or non-JSON file, it's going to list everything. We can actually filter it just for clarity. Let's run this code because that code has no dependency on any other action because this is just a listing all the indexes in this index data folder. Run this code, list indexes, and as you can see there are 2 indexes available, this and that. So we could actually select any of the index here, drop here, and then we can say load index. That's the next item. So the load index is here, index file name and index selection action. Click. So we need another method which can select the index here, query index. So this is the place where we set up the index here. So we need to write a method. So this is the method which actually selects the index, self dot, then there is an input and there is the output. So input is the file name which is set as an index here. Output is this result. As you can see here that index status, self dot index status is what is the output from this method. What we actually do is that we just take the file name, we make sure we have a full path, we validate the file exists. If it exists, we just use this load from disk vector index, pretty simple vector index, exact same here. And that's what we have at the index, and then we set the selected index here. And then we just update the self.index status. So this self.index status is what the output of this method. So in this index file name, the output is our self.index status, index status label. So index status label is this value. So let's set this thing up. So now we have index file name and index status label. So once the index status is set here, then we can ask question. So let's complete this method also, then we will validate this method and this method. So the next we need query data action dot click, and we need input query question. Here is the method is coming here, so I will just write method first and then I will replace that. So input question and the output is query result text, and I need a method here which is going to take the text as an input. After index is set up, here is our prompt. So whatever the index is, we are going to ask the prompt here. So this is our method here, self dot, there you go. So this is our method which is going to process the question. So as you can see here that this is the index, and here we are going to get the answer. So let's run this code and validate these two methods. And remember, when we are performing this query, we don't really need to fine-tune because we have already fine-tuned the data earlier, LLM with our custom data earlier. It means we can just load the index and ask the question. So we don't really need to test these two for validating this tab. It is loaded. As you can see here the indexes we have, we can select this index. Let's load index. Now index name is checked, and as you can see here index name is there, but our API key is not set here. That's why we are getting this error, index is not selected. So we still need to set up the API key. API key is set. Now we come back here and we try to set up or load the index. Now our API key is not none. We got the index path. Now we are loading the index from the disk. Here is the index. We made a call to, and I think this loading index does not require any call to the backend because we are loading the index, and this is the call within the GPT Index library itself. So index is set, self.selected index, which we have created here earlier as a class property. So our index is set because that's where we are going to reuse it. So once the index is set, this message shows that index is set. Now it means we can ask question. So what is this document about? That's question, and this is the question we are asking, and we are selecting. If the selected index is not none, we are making a request. So when you are selecting the index and passing the query, that's where the call to backend is going to happen. The API key will be used to make this call. And as you can see that we made a call to OpenAI, we have got the result back here. And this is the result back which will be sent as the output. Let's run it. And here's the output of our. Now, if you would want to use a TXT file, we can actually validate this very quick as well. So I will go ahead and I will remove all those breakpoints so we will not get any interrupted execution. So here is a TXT file I have, very small. We are creating the index. Index is created. We can come back here. We can load indexes. So this is the index we have just created right now. I will load this index. I do not know what is this document about. I can ask question. This document is about how artificial AI can transform the DevOps. You can say who are the authors. The authors are these two. And here is the summarize or the summary of our document. So this full code is what you really needed to make this Gradio UI based application to fine-tune your LLM model with your custom document and finally ask queries around it. And as you can see that here are the OpenAI connectivity or the calls we have made during the execution of this application. So you can see that how many tokens exchange happens between our application to OpenAI and the results came back. So this is how you are being charged based on the tokens you are using for every request. There are two separate calls, total LLM token used and total embedding tokens usage. So here you are seeing that LLM tokens, embedding tokens, and here I'm showing you the real time, the charges or the request made with my OpenAI account. And when you are seeing the LLM tokens, you are actually getting the tokens which are coming out from the DaVinci LLM model. And the tokens are combined with whatever request we have. So this actually result is up to 9:45 a.m. So this number will not match because that data is not updated in the OpenAI interface for usage, but this is for the previous one when we have used the PDF document. This text document is really very small comparative to the PDF document. So here, as you can see that when we make request to the model, this is what was prompt and these are the tokens. So total tokens are here. This is the embedding tokens when we are actually using the embeddings against the in order to generate the index. So this is how your pricing is, and in order to build this tutorial for all that thing, I think it would have cost me about 25 cents around. It's still significant in long run, but at least it gives you idea that how you can utilize an existing infrastructure such as OpenAI to fine-tune your LLM model with the custom document. This full code which we have covered in this tutorial, I have already updated to my DeepWorks GitHub repo. You can go look into this ChatGPT section, fine-tune LLM. And in this fine-tune LLM, you can actually see the code is available here. Tuning Gradio UI code, everything is here. However, if you can just go to this folder where you can find all these 3 files in this project which we have used. So that's all I had for you in this video. In the next video, I'm going to extend this application and I will add the Whisper UI so that you can actually ask questions directly by using the webcam, and you are going to get responses also in the terms of audio. Thank you so much for your time. I do appreciate it sincerely, and I'm looking forward to seeing you in my next video. Until then, thank you so much.